Okay, let's get into it. We're going to talk about one of the biggest what-ifs imaginable. What if a giant rock from space was heading right for us? Could we actually do anything about it?
So let's just jump right into the scenario. Picture this. Astronomers spot a massive asteroid, about the size of a football stadium, and it's on a direct collision course with Earth. And the really bad news? We only have 2 weeks. What happens next? Are we just done for?
It's hard to even wrap your head around the stakes here. An impact like that would release the energy of 4,000 Hiroshima bombs, all at once. That's enough to flatten entire cities and kick off a global catastrophe. So yeah, having a plan is probably a good idea.
And I know what you might be thinking. This sounds like the plot of a summer blockbuster. But here's the thing, it isn't. This is a very real threat that scientists and space agencies around the world take incredibly seriously.
And this isn't just some abstract threat. These close calls happen. Back in 2019, an asteroid big enough to wipe out a city flew past us, and we only spotted it 1 day before it got here. 1. And just last year, an even bigger one gave us only 13 days' notice. The only reason we're okay is, well, we've been lucky.
So what about our current plans? You hear about ideas like painting one side of an asteroid white to let the sun push it, or landing tiny thrusters on it. And those are cool ideas, but they need decades to make a difference. With only a few weeks' notice, it's completely useless. It's like trying to change the course of a giant cargo ship by standing on the dock and throwing potatoes at it. It's just not going to work.
Okay, so if the gentle nudge approach is out, what about the opposite? The Hollywood solution. Let's just nuke it. It seems so simple in the movies, right? But the reality of space makes this a whole lot more complicated than you'd think.
So let's quickly run through the 3 main ways you see this play out in fiction and talk about why in the real world it'd probably all fail. First up, the direct impact. Just fly a missile right into the asteroid. The problem is speed. These things are moving at unbelievable velocities, like 70,000 kilometers an hour. At that speed, the asteroid would just vaporize the missile and the nuke on impact, literally faster than the bomb could even detonate.
All right, so plan B. Detonate the nuke near the asteroid, a standoff explosion. But this fails because of one simple fact. Space is a vacuum. Here on Earth, an explosion is powerful because it creates a shockwave by pushing the air. In space, there's no air to push. Most of that incredible energy just radiates away into nothing, barely even scuffing the asteroid's surface.
And of course, there's the big one, the whole Armageddon plan. Land a team of heroes, drill a deep hole, drop the bomb in. It makes for a great movie, but in reality, it's a logistical nightmare. Trying to land on a spinning, tumbling rock in microgravity, and then trying to drill into it, it would be agonizingly slow. With only a couple of weeks, it's pure fantasy.
So, if brute force isn't the answer, what is? Well, it turns out we need to stop thinking like we're in an action movie and start thinking with a little more finesse. It's time to think more like a lumberjack.
Think about it. If you want to split a giant log, you don't just hit it with a big round boulder, right? No, you use an axe, a tool that's specifically designed to get inside the wood and use focused energy to split it from within. That is the crucial insight here. We don't need a bigger hammer. We need a cosmic axe. And here it is. Scientists call it a penetrator. Now, this isn't a bomb or a missile. It's basically a giant, super dense dart made of tungsten. And here's the beautiful part. We don't even have to fire it. We just have to put it in the asteroid's way and let the asteroid's own incredible speed do all the work.
So here's how the mission would go down. For that stadium-sized asteroid, we'd launch a single rocket. It would take about a week to fly out a couple million kilometers from Earth and deploy one 2.5-ton penetrator. Then it just waits. The asteroid, screaming along at 70,000 kilometers an hour, slams into this stationary object. The kinetic energy from that impact is so immense, it vaporizes the asteroid from the inside out, shattering it into a cloud of tiny bits that would just burn up in our atmosphere like a beautiful, harmless meteor shower. Problem solved.
But what if the thing coming at us isn't the size of a stadium? What if it's the size of a mountain? A true planet killer? Well, then the rules of the game change completely.
See, the really big threats, the extinction-level events, are often long-period comets. They're mostly ice and rock, but they come screaming in from the outer solar system at double the speed. We're talking 140,000 kilometers an hour. And since kinetic energy increases with the square of velocity, their destructive potential is, well, it's astronomical.
And against a monster like that, our elegant penetrator solution just isn't enough. If you just shatter it, the pieces would still be big enough to wipe out civilization. To be safe, you'd have to completely obliterate it way out past Mars. And that would require an absolutely insane amount of penetrators and about 24,000 launches of our biggest rockets.
24,000 super heavy rockets. Let's put that in perspective. Right now, on the entire planet, we have exactly 2 types of rockets that could even try this, and neither of them is even fully operational yet. So if we saw a planet killer coming today, we'd be helpless. Or would we?
This is where it all comes together. We take the precision of the penetrator and combine it with the raw, brute force of the Hollywood nuke. This is the hybrid solution. Humanity's one last shot. The mission would be an epic journey. A single rocket launches on a 5-month trip out beyond the orbit of Mars to meet the comet. Once it's in position, it deploys a string of 5 massive penetrators, all lined up in a perfect row, right in the comet's path. This is our one and only chance.
And this is the grand finale. The first 4 penetrators slam into the exact same spot on the comet, one after another, basically drilling a 100-meter deep tunnel straight into its heart. And then comes the 5th and final penetrator, only this one is carrying a passenger, a massive nuclear warhead. It travels down that freshly carved tunnel and detonates deep inside the comet, unleashing its power from the inside out.
By setting it off deep inside, none of that energy is wasted in the vacuum of space. It's all contained, ripping the comet apart from its very core with the force of 20,000 Hiroshima bombs. The planet killer is vaporized into nothing more than a harmless cloud of dust. Humanity is saved.
And you know, the most incredible part of this whole audacious plan? It's not science fiction. This isn't technology we need to invent in 100 years. The rockets, the materials, the engineering know-how, we have everything we need to build this system right now.